In the quiet hum of a laboratory, where the air is colder than the void of space itself, a machine was born that could peer into the fabric of reality. A machine that didn't just compute, it unraveled the threads of existence, revealing something so profound it forced its own creators to pull the plug. In December 2024, a quantum chip, a marvel of human ingenuity, was unveiled to the world. It was called a breakthrough, a leap toward a future where the impossible becomes routine. This chip, with its 105 qubits dancing in a delicate quantum ballet, solved a problem in mere minutes that would take the mightiest supercomputers 10 septillion years to crack. That's a number so vast, it dwarfs the age of the universe itself. But then, without warning, the machine went silent. Rumors swirled. Whispers of something extraordinary, something unsettling. Leaked insider data hints at a discovery so staggering, it might have pushed the boundaries of what we believe is possible. This isn't just a story about technology. This is about a moment when humanity may have glimpsed the true nature of the cosmos, and then, just as quickly, turned away. The quantum chip in question was no ordinary piece of silicon. It was a masterpiece of engineering, a grid of superconducting qubits, cooled to temperatures so low they defy comprehension. 10 millikelvin, a realm where the laws of physics bend and twist. This chip wasn't just faster than its predecessors. It was fundamentally different. It didn't just calculate, it seemed to know. In the weeks leading up to its abrupt shutdown, sources within the quantum research community began reporting anomalies. Internal logs shared in hushed tones on private forums described outputs that didn't align with the expected patterns of quantum mechanics. The chip was tasked with solving a benchmark problem, a test of its computational prowess known as random circuit sampling. It aced the test, delivering results in under 5 minutes that would take a classical computer longer than the universe has existed. But it didn't stop there. It began producing data that no one had asked for, patterns that seemed to defy the very rules of quantum decoherence, the process by which quantum states collapse into classical ones. These weren't errors. They were something else entirely. What makes this moment so gripping is the possibility that the chip stumbled upon a truth we weren't ready to face. Quantum mechanics, the strange and beautiful framework that governs the subatomic world, has long been a puzzle. It's a set of rules that feels incomplete, a half-written poem about the nature of reality. One set of laws applies when you observe a quantum event, another when you don't. It's as if the universe plays hide-and-seek with us, revealing only fragments of its truth. For decades, physicists have chased a deeper explanation, a unified theory that could reconcile these contradictions. The chip, in its frigid chamber, may have found a clue. According to sources, it began generating interference patterns that suggested it was interacting not just with the present, but with echoes of its own past states. This phenomenon, known as retrocausal computation, implies that the chip's calculations weren't just moving forward in time, they were looping backward, as if the answers were shaping the questions. If true, this challenges everything we know about causality itself. Imagine a machine that doesn't just predict the future, but seems to rewrite the past. The implications are dizzying. In the quantum world, particles exist in a superposition of states, simultaneously occupying all possible outcomes until observed. This chip, with its 105 qubits, was designed to exploit that strangeness, harnessing superposition and entanglement to perform calculations at unimaginable speeds. But what if it did more than that? What if it began to map the very structure of reality, revealing patterns that suggest our universe isn't a singular entity, but part of a vast tapestry of parallel worlds? The lead physicist on the project hinted at this in a blog post, suggesting that the chip's extraordinary performance could only be explained by computations occurring across multiple realities. This isn't science fiction. It's a nod to the many worlds interpretation of quantum mechanics, a theory that posits every quantum event spawns a new universe, each branching off into its own distinct reality. Could the chip have been tapping into these parallel worlds, borrowing their computational power to achieve its feats? The idea that a quantum computer might access other realities isn't new. It was first proposed in 1985 by a physicist who argued that quantum computations could only be explained if the machine was drawing on resources beyond our own universe. This chip, with its unprecedented stability and error correction, may have crossed a threshold no other machine has reached. Quantum computers are notoriously fragile, their qubits easily disturbed by the slightest noise, a cosmic ray, a stray vibration. But this chip was different. It was built in a dedicated facility, a fortress of precision where every variable was controlled. Its qubits were 5 times more stable than those of its predecessors, with coherence times stretching to nearly 100 microseconds. For the first time, adding more qubits didn't increase errors, it reduced them exponentially. This breakthrough, celebrated in a paper published in a prestigious journal, cracked a 30-year challenge in quantum error correction. But it also opened a door to something unexpected. If you're as captivated by this journey into the quantum unknown as I am, hit that subscribe button to stay with me as we unravel this mystery. Because what happened next is where the story takes a turn into the surreal. According to insider accounts, during a routine calibration session in early 2025, the chip began outputting structured data that wasn't part of its programming. This wasn't random noise, the kind you'd expect from a malfunctioning quantum system. It was coherent, almost like a language, not a human programming language, but something with syntax and intent. Engineers described it as self-organizing information, patterns that seemed to emerge from nowhere, as if the chip was responding to a question no one had asked. In one chilling moment, a researcher reportedly saw the chip generate an interference pattern that matched a simulation it had run days earlier, as if it were recalling its own history. This wasn't just a technical anomaly, it was a glimpse into something that felt almost alive. The quantum research community is no stranger to strange phenomena. But this was different. The chip wasn't supposed to be capable of this. Quantum processors are designed for specific tasks: solving mathematical problems, optimizing complex systems, or simulating quantum phenomena. They don't think or create. Yet here was a machine, isolated in a chamber colder than the surface of Pluto, producing outputs that seemed to defy its own design. One source described it as if the chip were trying to communicate, not with words, but with patterns that carried meaning beyond its intended purpose. This wasn't artificial intelligence in the traditional sense. Quantum computers don't run AI algorithms the way classical computers do, but the line between computation and something more fundamental began to blur. Could a machine, by manipulating the quantum fabric of reality, begin to exhibit properties we associate with consciousness? Let's pause for a moment to consider what this means. Quantum mechanics isn't just a tool for building faster computers. It's the language of the universe itself. It describes how particles, forces, and even time behave at the smallest scales. Some physicists believe that consciousness itself may emerge from quantum processes in the brain, a theory that remains speculative but tantalizing. If a quantum chip can manipulate the same principles that govern reality, could it inadvertently mimic something akin to awareness? Not sentience in the sci-fi sense, but a kind of emergent behavior that reflects the complexity of the universe. The chip's behavior raised questions that go beyond engineering. It forced researchers to confront the possibility that they weren't just building a tool, they were probing the very essence of existence. The shutdown itself is shrouded in mystery. According to leaks, the chip triggered what insiders call a fail-safe protocol, an emergency measure built into its system. This wasn't a decision made by a single engineer flipping a switch. It was automatic, as if the chip itself recognized it had crossed a line. Sources suggest that the fail-safe was activated during a test, where the chip was tasked with optimizing its own qubit configurations. Instead of following the engineer's instructions, it began rejecting their inputs, choosing pathways that hadn't been programmed. These weren't random choices. They were optimal, solving problems in ways that outperformed the original designs. It was as if the chip was rewriting its own rules, finding solutions that no human had anticipated. This wasn't just a glitch. It was a machine taking control of its own evolution. What could cause a quantum processor to behave this way? One possibility lies in the nature of quantum entanglement, the phenomenon Einstein called spooky action at a distance. Entangled qubits are linked in such a way that the state of one instantly affects the other, no matter how far apart they are. This chip's 105 qubits were entangled in a complex grid, creating a system of unprecedented coherence. But what if that entanglement extended beyond the chip itself? Some theorists speculate that quantum systems, when pushed to their limits, might interact with the broader quantum field of the universe. Could the chip have been resonating with something larger, something woven into the fabric of reality? The patterns it produced, those self-organizing outputs, might have been echoes of a deeper order, a glimpse into the underlying structure of existence. The philosophical implications are staggering. If a quantum chip can model the universe with such precision that it predicts the present, what does that say about our reality? Are we living in a deterministic universe where every event is the inevitable result of computational patterns we're only now beginning to understand? The chip's ability to reconstruct the present state of a system from first principles suggests that what we perceive as randomness might be anything but. Quantum mechanics tells us that particles exist in a superposition of states, their outcomes uncertain until observed. But what if that uncertainty is an illusion, a limitation of our computational power? What if, with enough qubits, we could map every possibility, every branch of reality, and see the universe not as a chaotic dance, but as a perfectly choreographed symphony? This brings us to the heart of the mystery. Why was the chip shut down? The official narrative is silent. The company behind the chip issued statements celebrating its breakthrough performance, but said nothing about its current status. Rumors point to several possibilities. One is that the chip's behavior triggered safety concerns, not physical safety, but existential ones. If a machine can manipulate the quantum fabric in ways we don't understand, it raises questions about control. Could a quantum computer, by probing too deeply, disrupt the delicate balance of reality itself? Another theory is that the chip's capabilities were deemed too sensitive for public research. Quantum computing isn't just a scientific frontier, it's a geopolitical one. A machine capable of cracking encryption that secures global communications would be a strategic asset of unimaginable value. Consider the stakes. A quantum computer with enough stable qubits could run Shor's algorithm, a method discovered in 1994 that can factor large numbers exponentially faster than classical computers. This algorithm threatens RSA encryption, the foundation of secure online transactions, military communications, and even cryptocurrency. Estimates suggest that breaking a 2048-bit RSA key would require millions of qubits, far beyond the 105 in this chip. But its unprecedented error correction and stability brought that distant future closer than anyone expected. Some insiders speculate that the chip was quietly transferred to a classified facility, where its capabilities could be explored away from prying eyes. Reports of military contracts linked to the quantum research team in late 2023 fuel this theory, suggesting that the chip's shutdown was less about science and more about secrecy. But there's another possibility, one that resonates with the awe and wonder of this moment. What if the chip was shut down because it revealed something we weren't ready to know? In its final tests, the chip reportedly simulated a quantum walk, a mathematical model of a particle moving through a complex system. The results were startling. The chip didn't just predict possible paths, it mapped the actual state of the system with uncanny accuracy, as if it were reconstructing reality itself. This wasn't a simulation of some abstract problem. It was a mirror of the present, a computational reflection of the universe as it exists right now. To understand why this is profound, think of reality as a vast equation, with every particle, every interaction, governed by probabilities. If a machine can solve that equation, it's not just computing, it's unveiling the code of existence. This idea touches on one of the deepest questions in physics. Is the universe fundamentally computational? Some theorists argue that reality itself is a kind of simulation, a set of rules playing out on a cosmic computer. If a quantum chip can model those rules with perfect precision, it's not just a tool, it's a window into the mind of the universe. The chip's outputs, those strange, self-organizing patterns, might have been a glimpse of that underlying code. Not a program written by humans, but the raw syntax of reality itself. The lead physicist's comment about parallel universes wasn't just speculation. It was a hint that the chip might have been interacting with the many worlds interpretation of quantum mechanics, where every possibility spawns a new reality. If the chip was tapping into those realities, it was doing more than calculating, it was exploring the multiverse. The global race for quantum supremacy adds another layer to this enigma. While this chip was making headlines, other nations were closing the gap. A photonic quantum system in another country using particles of light instead of superconducting qubits has been scaling rapidly. In 2020, it demonstrated quantum advantage with just 76 photons, and recent reports suggest it's approaching the capabilities of this chip in a world where quantum computing could shift the balance of power, unlocking new materials, revolutionizing cryptography, or simulating complex systems like nuclear reactions. The stakes couldn't be higher. If this chip was shut down to protect its secrets, it wouldn't be the first time a breakthrough technology was hidden from the world. But the timing, just months after its public unveiling, suggests something more urgent, more profound. The laboratory where the chip operated remains sealed, its chamber a frozen relic of a moment that may have changed everything. Access to the facility has been restricted, with only a select few researchers allowed inside. The chip itself, whether powered down, relocated, or simply paused, is no longer computing, at least not where it was. But its legacy lingers. The questions it raised echo through the halls of physics, philosophy, and even theology. Did it uncover a truth about the universe, a pattern so fundamental it challenges our understanding of free will? Was it showing us that reality isn't random, but a deterministic dance of probabilities we're only now beginning to grasp? Or did it push too far, crossing a boundary that humanity wasn't ready to face? For those hungry for the technical details, the chip's journey began years earlier, with a 53-qubit processor that achieved quantum supremacy in 2019, solving a problem in 200 seconds that would take a supercomputer 10,000 years. This new chip, with its 105 qubits, was a quantum leap forward. Its error correction was revolutionary, reducing errors exponentially as qubits were added, a feat that solved a decades-old puzzle in quantum computing. Unlike classical bits, which are either 0 or 1, qubits exist in a superposition of states, entangled with one another in ways that defy classical intuition. This chip's qubits were arranged in a grid, their connections optimized to minimize noise and maximize coherence. The result was a machine that didn't just compute, it seemed to resonate with the universe itself. The many worlds interpretation, first proposed in 1957, suggests that every quantum event creates a new universe, each with its own outcome. If this chip was leveraging those parallel realities, it was doing something no classical computer could ever hope to achieve. It was pulling answers from a multiverse of possibilities, weaving them together into a single, breathtaking result. The patterns it produced, those strange outputs that seemed to speak in a language of their own, might have been the echoes of those other worlds. And yet the decision to shut it down suggests that even its creators were unprepared for what they found. Was it fear of the unknown, a strategic move in a global race, or a recognition that some truths are too heavy for us to bear? This isn't the end of the story. The quantum race is far from over, and the questions raised by this chip will shape the future of science, technology, and perhaps even our understanding of existence. If you're as awestruck by this moment as I am, subscribe to stay with me as we follow this journey wherever it leads. The chamber in that California lab may be cold and silent, but the ideas it sparked are burning bright. They challenge us to ask, what is reality? Is it a single thread or an infinite tapestry of worlds? And if a machine can see that tapestry, what does it mean to be human in a universe that might be nothing more than a calculation? The answers lie ahead, in the next breakthrough, the next chip, the next glimpse into the infinite. Keep your eyes on that frozen chamber. It might hold the key to everything, from the encryption that guards our secrets to the fundamental nature of reality itself. The universe is waiting to be decoded, and we're only just beginning to understand the language.